Before I introduce the next two speakers, I just want to return to the purpose of the framework, really, because what the framework is, if anybody is still confused by at this stage in the day, is an evidence-based specification, comprehensive in scope and content, of the domain of mathematical understanding and operation. And in a form which is not intended to be sort of epistemically arrogant, that this is it for all time, but to specify the domain in such a way that different assessments and programs can be developed to meet different needs, but rather than them then appearing as kind of incoherent, disparate groupings of things, the specific content of each can be understood, and the relations between them can be understood. And why do we want that? Well, Jeremy Hodgen's work, that's why. That's one example of why we need it, because it's very clear that we had A-levels, we had GCSE, we had functional skills, but we didn't have anything in our system, in contrast to some other international systems, which provide an appropriate maths programme and certification for those going on to HE to study social sciences, but not studying A-level English. For them, GCSE research, not useful. They may have got A star, but we want them to continue with a mathematical programme to develop their understanding, which is commensurate with the demands of those kind of programmes, which are becoming increasingly demanding in terms of their mathematical literacy. So it is about developing a framework by which we can derive programmes and qualifications in that way and see how they relate, understand progressive ladders so that people, if they are moving from this stage to this stage and in this direction and this direction in terms of the economy or in terms of general education, you can understand the steps, you can understand each of the blocks. Okay, and indeed South Africa said, look, there's a problem between articulation between IGCSE and International A-level. There's a gap between them. Well, that's precisely the kind of gap that we want to manage carefully and coherently through the framework. There we go. So, introducing the two speakers, we have Madam Toh Hoon Sin and Will Hornby. A couple of words about Singapore. Having worked with and done some observation in schools in Singapore, I'm incredibly impressed by two things. One is indeed the incremental way in which all things in the Singapore system are examined and systematically improved carefully. And for those who say, well, it's completely command style and top-down, they are just repeating naive assumptions about the Singapore system. The Singapore system is an incredibly rich system of transfer between the bottom and the centre and back out into practice. Officials rotate between teaching and being members of ministries. There have been those like Fei Shen, who over 2 to 3 decades have been involved in identifying optimal pedagogy in relationship to mathematics, ensuring that those are embodied within, that's embodied within the criteria used for the development and scrutiny and approval of state-approved textbooks, that those textbooks are systematically improved over time, that those materials are accompanied by CPD, which again embodies and communicate the ideas, for example, Brunerian, concrete, iconic, abstract, such that those ideas, as well as the specific practices, are embedded and understood consciously and deliberately right the way across the system. I'm also impressed by the second point, Singapore, by the extent to which evaluation work is done, and it's not embarrassing to find that something doesn't work. It's just that it's been tried and it doesn't work. So it's no longer endorsed by the government as a viable way forward. And they do a lot of evaluation because they know that they need a lot of candidates to look at, because not all of those candidates for improvement are necessarily going to work. So I think it's a very rich, mature educational environment in which there are a huge number of transactions between the centre and the periphery, between the periphery and the centre. And we'll hear some of those now. Will Hornby is from OCR and importantly embodies a commitment to subject expertise. If we think about the kind of development of and distillation and development of good practice, we used to have HMI. We used to have subject experts. We used to have HMI specialist reports, and they bridged between advising and inspecting. They distilled, they represented, and they disseminated. At Cambridge, we continue to think that examinations and their accompanying materials have the same function. but they need to be mediated through acute expertise in respect of the subject and more generally in terms of pedagogy. And it's in terms of those issues that Will Hornby will be presenting today. So can we please welcome our first speaker, Madam Toh Hoon Sin from Singapore.
Okay, thank you for this opportunity to share a little bit of how mathematics is assessed in Singapore. There's been a lot of questions asked about Singapore mathematics, and I hope after my presentation, some of your questions are answered. Okay, I'm not going to, give too much time to see the slides because I've been reminded that I only have 15 minutes. Okay, this is Singapore's rationale for including mathematics in the school's curriculum. These are reasons at the nation's level, and these are reasons at the individual's level. And I just think you'll find them very familiar. They are the same for most, if not all, countries. Okay, so there's no need to spend too much time on these two slides. Okay, what I would like to share with you is this: how our systems for maths is set up. So every student in Singapore will have received at least 10 years of maths education by the time they leave secondary schools. Okay, the Singapore maths curriculum consists of a set of connected syllabuses to cater to the different needs and ability of students from primary 1 to pre-university 2. Okay, mathematics is largely hierarchical in nature. So higher concepts and skills are built upon the more foundational ones, and they have to be learned in sequence. We adopt a spiral approach in the design of the maths curriculum, building on the content as students progress up the levels. So the primary 1 to 4 syllabus is common to all students. The primary 5 and 6 standard maths syllabus continues the development of the primary 1 to 4 syllabus, whereas the primary 5 and 6 foundation maths syllabus revisits some of the important foundational concepts and skills in the primary 1 to 4 syllabus. There was a question asked, are there no weak performance in mathematics in Singapore? Yes, we have. That's why we have this foundational maths syllabus to cater to this small group. So the concepts and skills introduced in foundational maths syllabus is a subset of the standard maths syllabus. Okay. The O-level maths syllabus builds on the standard maths syllabus. The normal academic level maths syllabus is a subset of the O-level mathematics, except that it revisits some of the foundational topics in standard maths syllabus. And then we have the normal technical maths syllabus, which builds on the foundation maths syllabus. So you'll notice that by design, we do have different pathways for our different groups of students. Okay, the normal academic and the normal technical are to cater to those who need more time to complete the syllabus. They do have a different sets of syllabus outcomes. We also have O-level additional maths syllabus, which assumes knowledge of O-level maths content and includes more in-depth treatments of important topics. The normal academic level additional maths is a subset of O-level additional maths. And the O-level additional maths, together with the O-level maths, they would provide the prerequisite knowledge required for H2 mathematics at the pre-university level. So at the pre-university level, mathematics is optional. The H1 mathematics syllabus will build on the O-level maths syllabus, and the H2 maths builds on the O-level maths and some of the O-level additional maths content. H3 maths is the highest, and it's an extension of H2 mathematics. So you can see how our curriculum is designed in such a way to support the higher levels. Just to share a little bit about our recent syllabus review. The recent syllabus review takes on broad curriculum-wide recommendation from the Ministry's 21st Century Competencies Framework. This framework is used across all subjects in Singapore. These recommendations include seeking a better balance between content and skills, developing 21st century competencies, making learning timely and relevant, embedding ICT and rich learning experiences, and harnessing assessment to support learning. I think you saw the pentagon in one of the presentations earlier. So this pentagon, this mathematics framework has been a feature of our maths curriculum since the 1990s. And it is aligned to the 21st century competencies. So that's why it remains relevant. We have not changed it. For the review, there were actually minimal changes in content across all the syllabuses. For our recent review, the emphasis is placed on mathematical processes, which is applying maths concepts and skills to solve problems in a variety of contexts within and outside mathematics, and understand the nature of the mathematical modeling process: reasoning, communicating and connections, thinking skills, and heuristics. So there were 3 key ideas that surfaced from this round of review. They are to sharpening the focus of each syllabus, emphasizing the mathematical processes which I mentioned earlier, and then influencing teaching and learning. We have more than 10 maths syllabuses spanning 12 years of the education. Each syllabus has a specific purpose, addressing different profiles of students and meeting different learning needs. Despite the differences, there are common goals as spelled out in the mathematics framework to be achieved in the learning of mathematics for all students. With this review, the aims of the syllabuses were further differentiated so that they could provide clearer focus in terms of what and how teachers should teach and how students should learn, developing process skills through a mathematical approach to problem solving and inculcating positive effects towards mathematics. Okay, you might be interested in this. I'll just touch on learning experiences. That's new in this current round of review. Learning experiences describes the opportunities that students should have as part of the learning process in terms of approaches, context, processes. Learning experiences were introduced by our curriculum colleagues to influence the way teachers teach and students learn, so that the curriculum objectives can be achieved. The learning experiences are included in textbooks, the print version, and online teaching and learning guides to guide the teaching and learning of the topics. Okay. So, it is hoped that teachers and students have opportunity to carry out the learning experiences. Yeah. Okay, last year was the first year of exam for many subjects after this round of syllabus review. And this was the article that appeared in our Singapore Straits Times on 24 February, after the results was out. So the feedback from our students was that if you want to do well in the examination, it is not enough to just practice the 10-year series. I'm not sure whether you have this 10-year series, where the students will go through all the past year's papers, Yeah. So it's not enough to practice all the questions in the 10-year series, as they are not required to apply the concepts that they have learned in new contexts. Okay, I was assigned the primary section for this part of the presentation, so I better stick to that now. So for the rest of my presentation, I'll be talking about how maths is carried out in primary school and how the assessment is done. These are the aims of the primary maths revised syllabus. The revised syllabus was implemented in 2013 for the primary 1 cohort. This group is now in primary 3, and they will be taking the primary school leaving examination in 2018 when they're in primary 6. Okay. Okay, for this round of syllabus review, we have reorganized the content. It's reorganized along 3 content strands, namely number and algebra, measurement and geometry, and statistics. And does it look familiar to you? It was done totally independently. Yeah. The mathematical processes cut across the 3 strands. Okay. When our students enter primary 1, the syllabus assumes no formal learning of mathematics. Okay. But when they enter primary 1, all the students would sit for the screening exercise in mathematics. Okay, students who are found to have weak numeracy skills are identified for learning supports in mathematics program, or we call it LSM for short. LSM is an early support intervention program for primary 1 and primary 2 students who are identified to be weak in basic numeracy skills. The focus of LSM is on basic mathematical concepts and skills to build a strong foundation in numeracy. It aims to build students' confidence and positive beliefs about their ability to do maths. Students in the LSM program receive more individual attention from teachers, and they also receive help in specific areas that they are weak in. Students learn in a conducive environment with smaller teacher-to-student ratio. They learn through varied activities, many of which are hands-on experiences. And then we have a second program that is called Improving Confidence and Achievement in Numeracy, or we call it ICANN for short. It complements the LSM program. It provides support for students who are showing low progress in primary 1 and 2, but they are not identified under the LSM program. Now, without the support, these students would risk failing mathematics in school. This, in turn, would limit their post-secondary or career options. So the ICANN program aims to equip teachers of such students with the knowledge, skills, and resources so that they can better support these students in their learning. So that's part of their teachers' development. Teachers learn to use intervention strategies that are guided by research to tackle the challenges faced by these students in the learning of mathematics. Okay, school support is important. Okay, so school support is available to facilitate this professional development of efforts of this group of teachers and to ensure sustainability of the effort within the school. At the end of 4 years of studying a common maths curriculum, all the primary 5 students are offered either the standard maths or the foundation maths syllabuses, depending on their aptitude in mathematics, as demonstrated by the performance in the primary 4 school-based examinations. Majority of the students would offer standard maths. And for the small minority of students who need more time to learn, they could offer foundation maths. So at the end of primary 6, the students will take the PSLE, which stands for Primary School Living Examination. Just a little bit about PSLE, because that examination is totally handled by us, and we don't involve CIE in doing that examination. Whereas all the other examinations, the GCE, N, O, and A, CIE helps us to do that. Okay, PSLE maths syllabus is aligned to the primary maths teaching syllabus. The PSLE paper allows students to show their mastery of mathematical concepts and skills and to apply them in problem solving. The paper caters to primary 6 students of different abilities, and they include a range of questions from basic to challenging. Okay, there are 3 assessment objectives for PSLE standard maths, because this is meant for the majority, so I'll just tell you a little bit more about standard maths. Now, they are based on Bloom's taxonomy. We have 3 levels. The lowest level is, we call it knowledge, which requires students to recall specific maths facts, concepts, rules, and formulae, and perform straightforward computations. The next level is comprehension, which requires students to interpret data and use mathematical concepts, rules, and formulae, and solve routine or familiar mathematical problems. So the key word here is routine or familiar. And then the highest level is application analysis. This level requires students to analyze data and/or apply mathematical concepts, rules, and formulae in a complex situation and solve unfamiliar problems. So the key word here is unfamiliar problems. Oh dear, okay. Okay,
how are you going?
Okay, would you be interested to see some examples? Okay. Okay, the questions that we classify under assessment objective, application analysis are intended to assess problem solving, which is central to our maths learning. Okay, so you can see that it's right at the center of our framework. Okay, very briefly about our examination. The papers are pitched appropriately and aligned to the maths syllabus. Okay, so you can see that we have 2 papers, paper 1 and paper 2. The difference between the 2 is that lies in the use of calculator. Paper 1 is a non-calculator paper, while the use of an approved calculator is allowed in paper 2. Okay, I'm sure you're very interested in seeing, what kind of questions we give our students, based on the 3 assessment objectives. Okay, these are examples of questions that were classified under the assessment of objective knowledge. I'm sure you agree that these questions require students simply to recall specific mathematical facts, concepts, rules, and formulae, and perform straightforward computations. Okay, so this would be a typical K questions. Okay, these are questions that we would have classified under comprehensions. Okay, so this requires a little bit more demand cognitively. They require students to interpret data, use mathematical concepts, rules, and formulae, and solve routine or familiar mathematical problems. And how will our analysis and application questions look like? Okay, this is one example. Okay, the question is structured into parts, okay, to make them more accessible to students. So this is an example of a structured question of medium difficulty. Part A provides a scaffold for part B. So you may not have time to look at the questions, but I would like to show you how our students would approach the question. It may look very complex, but they have a way to make use of to simplify the information for themselves. Okay, this is a method that many would use. Okay, they would draw a model, okay, to help them see the connection between the given pieces of information. So they are able to do it very easily. This is another method that they could use. It's called the guess and check method, which is an acceptable alternative method taught in the syllabus. One more example, okay, and another example of the application and analysis question. Okay, this is not structured. We do have some questions like that in the papers, okay, to allow the students to demonstrate their thinking skills and their ability to apply their maths knowledge and skills to solve problems. Okay, what are our challenges? Okay. We have two main challenges in the assessment of mathematics at the national level. Okay, the first is to ensure that there are questions that assess problem solving. To us, that's a challenge because such questions have to have an element of unfamiliarity. The second challenge is that there's a lot of feedback from parents that their children's schools set very difficult examination papers to prepare their students for PSLE. This happened despite assurance that PSLE paper includes a range of questions from basic to challenging. So what we have done is we have released the PSLE in the exam format. That means exactly how their children would see it in the exam. Okay, that is to give, so that students have a better sense of the types and spread of questions to enable all students to show subject mastery and prepare well, not to over-prepare and to spend excessive time on drill and tests, but to free up time for play, for exploring interests, and for holistic education. So of course, when we release the PSLE in the exam format, it's also to remind students not to under-prepare, as PSLE can serve a good gauge of their mastery of the subject for the next phase of the learning journey. Okay, last slide. I was also asked to share some blue sky idea. So for me, because I'm in charge of assessment, what's most important is how to provide information on students' gaps in learning. So this will help teachers to provide timely intervention to close the learning gaps. Thank you for your attention.
Thank you. Well,
Good afternoon. Following on from the idea of blue sky, I've been asked by Lynn to do effectively some public blue sky thinking. So a few caveats before I start. This is blue sky. This is not necessarily a vision of the future. This is a look forward to as open a design space as possible. In design, it's always important to set up as many straw men as we possibly can. And I will probably go too far. So the central conflict that I want to address is this, that the 21st century workplace is technology rich. The problems in it are ill-defined. And the solution relies on information sources which are non-linear, which are dynamic, and which are open. Many problems are solved collaboratively, often at a distance, and problem solving involves synthesis of information from multiple sources. In contrast, in traditional mathematics assessment, and I generalise here, the traditional mathematics assessment restricts technology use. Problems that tend to be clearly defined and their solution relies on information sources which are direct, closed and static, i.e. only the things which are provided in the exam room. And all problem solving is done individually. There's clearly something wrong here, given the maxim that what you test is what you get. If we want learners to develop the skills necessary for the 20th century workplace, then we need to build those skills into assessment, and this will require a fundamental change. Now, I must say at this point that I'm not an iconoclast. This is not about destroying what we have. Mathematical literacy and procedural fluency are key, and I am, as I said before, going to go too far. But this is not about throwing away traditional assessment. It's about looking at what other sorts of things we might do in addition to that. So, what do I mean by 21st century skills? Well, if you ask different people, you'll get different answers. This is one particular categorisation by the Assessment of 21st Century Skills project based in Melbourne, which divides skills up into ways of thinking, essentially creativity, innovation, critical thinking, problem solving, that sort of thing. Ways of working, i.e. communication, collaboration, tools for working, which include information literacy and ICT literacy, and living with the world, citizenship, life and career, and personal and social responsibility. The current reforms in the UK address really ways of thinking. There's an awful lot of talk about problem solving and about interpretation and comprehension, but they don't really address any of the other three. Now, attempting to address these seems like a good idea, and addressing these ways of thinking in the current form is obviously a good thing, but it's only the first step. And the main change in the current form is really to do with type and balance of assessment items. The assessment instrument remains essentially the same. And within that assessment instrument, we are restricted in what we can test, and therefore what gets taught in the classroom in preparation for that assessment. And the key aspect I want to talk about here is the resources that we make available to learners during assessment. And I want to draw on something that Lynn said earlier, that this is a project which looks to 5 years' time. Not that we'll have an answer in 5 years' time necessarily, but we'll have a framework and a setup in 5 years' time that we can work with. This is about having ideas, doing design work, doing research, and providing an evidence base, so that when the next round of reform comes around, we have something that we can build on instead of sitting with essentially traditional assessment as we always have. So what are the resources that are available to students in their day-to-day life and available to all of us in our workplaces, but which are restricted in the exam room? I've gone for 4: time, other people, computation, calculation, and information sources. And I'll flick through the first two quickly and then talk more about the other two. So the first is time. This is my representation for time in the exam room. This student is not engaging in a creative activity necessarily. I think they're probably running up to 3 o'clock when the exam finishes. But increasing the amount of time in an exam room is very difficult without increasing the assessment burden on students. The only way of doing this is to take assessment out of the exam room in the first place. Now, we are being led always away from coursework, away from continuous assessment, and so on and so forth. I'm not sure that that's a very good idea, and I'd certainly be interested on your views. And if this is something we want to change, given that we've had a very clear steer in this current round of reform for traditional assessment in the exam room, it's something we need an evidence base behind us to convince policymakers that we need to do something about, getting students out of, here is your hour and a half, ready, steady, go. Other people, collaboration. Collaborative problem solving is obviously something that already happens in many classrooms. And assessing it directly might encourage more of that to go on, but the assessment of collaborative problem solving is challenging. In the first case, collaborative problem solving is highly dependent on group composition. So the particular group of students that you put together makes a massive difference to the outcome. And it is also highly important but not trivial to separate out the assessment of the final product as a whole from the assessment of the individual contribution to that product. Now, not an enormous amount of work has been done on this, but PISA 2015, which is almost upon us, will be looking at collaborative problem solving. So we do have a possibility of getting some data, some hard data across many jurisdictions to look at this. However, in order to assess collaborative problem solving, because of this group composition issue, in order to get the individual attainment out of it, you need to do an awful lot of trials. So individuals need to operate in multiple different groups on multiple different tasks in order to control for the various factors involved. PISA hasn't really addressed this. The intention is to use computer agents so that the students are assessed in their collaboration with the computer agent only, and potentially with multiple computer agents. So whilst they are looking at collaborative problem solving, they're really looking at a subset of collaborative problem solving skills and not necessarily at what people actually do in the workplace, i.e. work with human agents. So let's see what happens with PISA, and we'll wait with bated breath to see what comes out of that. But I think that this idea of collaborative problem solving is very important. So let's look at computation, calculation, information sources, which I'll deal with really together. And both of these resources are a form of offloading. In the first case of offloading of processes, and in the second case offloading of memory, essentially. And we offload in our lives computation and memory much more freely than we ever have, and particularly to technology. And much more young people do than perhaps older people. So it's difficult for us to get a handle exactly on what teenagers are doing with their offloading into technology. Within current assessment, the resources for computation essentially are a calculator, or in many cases, not even a calculator. And of course, so this is building from slide rules and log tables and so on. There's progression there, but we seem to have got a bit stuck on calculators. For information, again, in most assessments, no information sources at all. But increasingly, pre-release documents, formula books, there are changes being made, and particularly in core maths. In contrast, I'd like to dip briefly into my other job as a lecturer for the Open University. In most Open University maths courses, the exams are essentially open book. So students are allowed to take in with them their course book, in some cases actually the textbook, and they're allowed unrestricted annotation in that book. This frees them up, really, from a lot of this offloading. It allows them, to do an awful lot of offloading into that handbook, of the memorization of facts, of the recall of procedures and algorithms, and even terminology, so that students aren't stopped from answering a question because they don't remember exactly what that one word means. They can look it up in the handbook and get on with it. So it's just an interesting contrast. This stuff is already happening, and perhaps closed book examinations for mathematics are something we ought to think about moving from. And core maths, sorry, I've clicked slightly too soon, I'll come back. Core maths I just mentioned is blazing a bit of a trail at the moment. To some extent, the core maths qualification is this new post-16 qualification for those who are not doing A-level maths. It was mentioned by Tim Oates as a preparation for those going into higher education who need that quantitative skills, don't necessarily need calculus and coordinate geometry and so forth. And some of these qualifications allow for pre-release documents. Many operate with large data sets. There are even some that allow for the use of a PC, a locked-down PC in the exam room with some software. So we're starting to move there in the sort of mind extension sort of resources that are being allowed in assessment. And I mean, the use of pre-release documents and PCs in exams obviously isn't new. There are existing qualifications that do that, but they tend to be, particularly in the use of PC use, very small numbers. In comparison to day-to-day life, if you forget something, if you forget what the quadratic formula is, you can look it up. If you forget where the pluses and minuses are, you can look it up. Even better than looking up, you can look up the formula and do it, or even better than that, you can simply ask Siri. Those of you who have iPhones, and we've been playing around in the office this week with Siri. Siri is now linked up to Wolfram Alpha. It'll do all sorts of clever things for you. There's a slight problem with the voice recognition sometimes, and it sometimes finds interpreting what you're trying to get it to do difficult. But it's it's there. You can simply ask your iPhone to do a contour integral for you, or surface integral, to solve a differential equation. It's right there in your hands. And it takes about 5 seconds to get an answer back. So teenagers use this technology. They're probably already using it to cheat in their homework. Because Wolfram Alpha, if you're signed up, will give you the step-by-step as well. It doesn't just give you the solution. So we need to be aware of the fact this technology is going on. As was mentioned earlier, technology is always one step ahead of where you think it is. And school students, know much more about it than those of us who are designing assessment and curricula. So perhaps we ought to think about not second-guessing what technology they have access to and what they know. So the essential issue in assessment at the moment is that we want students to access some resources but not all of the resources available. We might think about allowing them access to their iPhone. Seems a bit risky. We might think about giving them access to the PC or a laptop. Seems a bit less risky. You can lock it down a bit. But as technology improves, all we're doing really is building up walls, higher walls, walls in different places. We're moving walls. My question for you is what happens if we just take the walls away? What happens if we simply release to students in an assessment all of the tools that they would have available to them in their day-to-day life? This sounds quite crazy. It's perhaps not quite as crazy as you might think, and it has been done. Here are some students taking exams with a computer, and you'll notice a Danish flag up in the top left-hand corner. In 2010, 14 pilot schools in Denmark took their exams with internet access, restricted only by the fact that they couldn't communicate with other people, so no Facebook, no email. This pilot obviously requires an awful lot of ICT skills and so on from students, but the ICT has been embedded in the curriculum for some time in Denmark. And there's been a lot of mention, a lot of talk today about incremental change. This wasn't simply thrown in 2010 as an idea. In 1994, they started to allow word processing in Danish exams. That word processing has been available for all exams since 2000. And as CD-ROM technology became more common, they started introducing CD-ROMs as a form of resource and a form of offloading for their exams. And this opens up the potential for resource in the exams to include videos, large sets of data and so on. It doesn't quite allow access to the internet. So it's always restricted. But at some point in 2008, they simply decided to see what happens if you took the reins off. And attempt this thing with internet access. So these students, this is for maths, by the way, it's not just in their Danish exams, they are using these in maths, and it does give them access to computer algebra systems, it gives them access to all kinds of information, terminology, algorithms, full works. So and it gives them access to research resources as well. So it may be that instead of giving them the data they need to solve a question, you can simply ask the question and they can use search engines to go off and find that information. Potentially, it allows for such things as serendipity within the exam. I'm quite struck by the idea that students might use in an exam a technique that they didn't know before they walked into the exam room. I think that's quite an interesting idea. And certainly that they use some form, some source of information that they hadn't come across before, simply by typing relevant items into search engines. It also, because if you allow the internet into the exam, teachers are going to use the internet in the classroom. There's all that serendipity that goes on in the classroom as well, all the research, the links that bring not just the algorithm, but the history behind the thing that you're looking at. Perhaps some of the romance, as was mentioned earlier, that the things link together and actually will enrich the classroom experience as well as the assessment. So what this does, what it changes about the assessment is that it moves away from traditional recall and towards assimilation, towards validation, towards analysis, towards synthesis. And I will repeat, as I said at the beginning, I'm not wanting to be iconoclastic about this. This is not the only future of mathematics education. Mathematical literacy, procedural stuff and so on is still important. This needs to be part of the picture only. But modelling and simulation are vital in the 21st century workplace. And they're not easy to do by hand, not effectively. So if we want students to be working with modelling simulation in the classroom, then we perhaps need to find ways of building these skills into the assessment. And this requires a step change in the resources that we allow in the assessment. So briefly, some of the obvious pitfalls that we have in opening up these sorts of resources. And the first is the obvious problem of infrastructure. And that's obviously such a big problem that I'm just going to brush it under the carpet and move on. And another obvious issue is cheating, in particular on the internet. And we need to redefine to some extent what we mean by cheating in an exam. What we need to do is to make it very clear with new resources what cheating means. So if sending an email to your teacher and getting an answer is cheating, then we need to say very clearly that communication with people outside the exam room is cheating. We need to make it very clear what plagiarism is. And plagiarism in mathematics is a very difficult thing if you're asking questions in an exam about routine calculation or about standard results. So perhaps we'd simply have to move away from asking the sort of question in the maths exam that you could simply copy and paste from the internet. And there's obviously a CPD and ICT skill issue here as well. So there's a skilling up both of the teaching population and of the students that needs considering. So the last thing I'd like to say is about the idea that assessment drives the enacted curriculum, which is something that we often hear. I think this is a truism, but that doesn't mean that the design of assessment should drive the design of the curriculum. We need to think about the curriculum we want and the assessment that matches that curriculum, and that doesn't include unintended consequences or emergent effects that we didn't intend as much as possible. So I think it's important to liberate assessment from this straitjacket of pen and paper and of calculators and of arguments about which calculator people are going to have and which calculator they can't have, and what formulas are in the formula book and what aren't, whether stats tables ought to be given or whether they get them off the calculator. This is all very, very interesting and very important to set up that we know what people are supposed to know, but perhaps liberating and just saying, well, they can know whatever they can find out would be a simpler and more valid way of doing it. And I do think it seems short-sighted to ignore this disjoint between assessment resources and those that are available in the classroom and the outside world. We have 5 years on this project. This is surely time to investigate what this is, to do some longitudinal is perhaps a large word, but some studies and to look at outcomes and to investigate this. Small-scale pilots are out there, and we need to think very carefully not only about the resource, the one thing I haven't got onto, but the assessment design. It's very easy to say, well, we'll just give them the same old tests with new tools. Actually, that's not a good idea. There needs to be a conversation about what sort of assessment task goes with these sorts of assessment resources. Thank you.
So the lights should go up and the questions should start, and we don't have any online questions at the moment. I just want to make a couple of observations while you're thinking of questions. I mean, the excellent work by Jeremy Hodgen on Tim's and other surveys and Margaret and colleagues at King's at the moment suggests that in respect of calculator use across a range of different nations, unlimited and unconstrained use of calculators within assessments is bad. Totally excluded, it's also bad, but controlled and constrained and carefully considered use is good in terms of overall attainment. I think it's also important, again, to think about some of the things that are going on in Singapore in relationship to what Will was saying. It's quite clear that if you look at what is called colloquially the Swiss role, with creativity, the student, innovation at the centre, and what might be considered subject-specific discipline knowledge around the outside, that some people have interpreted that as Singapore going for those things instead of absolute mastery of the 4 operations in number by the age of 11. But it's as well as, not instead of. And I think both Will and Madam Hun have actually emphasised that. Another small note on Singapore: Japan, high attainment in mathematics by the age of 11. Very, very good equity, low spread, and they don't like it much. Low enjoyment and low confidence. In Singapore, high attainment, high equity, compared with our system in terms of social background, and high enjoyment. So they are doing just something quite special in terms of the way in which their maths pedagogy is unfolding. That's very important. So these, not instead of, as well as, and emphasising high enjoyment, high equity and high attainment. It is possible. Just a brief note on your point about assessing group work, Will. There were some very angry medics down in St George's on PBL courses because they do a lot of assessment of group-based activities. And if you're a medic desperately trying to qualify, you get pretty fed up with the lazy member of your group. Now, what this results in most medical education programs that use these kind of innovative forms of assessment, is actually a lot more assessment. Because the way they get over those problems is to vary the group and actually have a lot more group assessment with variation across the cohort. But it all amounts to a great deal more assessment, which perhaps hints at what Will is saying, is that we need to integrate assessment into learning in new ways and not just think about traditional modes and having more of that. Okay, so questions on the matters that have been raised this afternoon. Could you say who you are and where you're from?
I'm Julian Gilbey. I'm from Cambridge Mathematics Education Project. Thinking about what Will was saying, a friend of mine is a lecturer up in Birmingham, and in their first year maths program, they've introduced a course whereby the entire course is group work and is group assessment. And they work on 2-week projects. They're given very open tasks, given some guidance how they might approach it, have access to internet and all sorts of things. And as part of the assessment process, thinking about what Tim is saying, they have to write it. I think 80% of their mark is on the group output, but 20% comes on the basis of a self-assessment of what part they played in the task and what part their colleagues played. So part of the assessment, they have to assess each of the people within the group, and therefore, if there is a free rider, they'll get found out pretty quickly. And also they're being assessed by people on the course. And I wonder if we can learn from universities like Birmingham and bring it into school level.
Can I respond?
Well,
yeah, there are forms of collaborative assessment within the Open University as well. And certainly, because of the distance learning aspect of the Open University, it's very difficult to get students together to do group work a lot of the time. It doesn't happen in mathematics, or at least not as far as I'm aware. I'm happy to be told that's wrong. But there are courses that involve collaborative group work on online forums. I mean, this allows for, obviously, for asynchronous collaboration, but it also allows for, it gives you a record of what's gone on. So actually, being a lazy member of the group is very dangerous because it's very clear from the forum that you've not been taking part in any way. And not only that, but it can look as if you've been taking part in the group a lot by posting an awful lot. But because your posts are all there, actually the extent of your contribution can be analysed as well. So there are ways. I think record keeping is a much better way, perhaps, than multiple groups.
Tony.
Tony Gardner. I hesitate to say it, but please don't learn from Birmingham and other universities. Universities issue their own degrees, and their status in national student surveys and elsewhere depends on them all getting very good degrees. So they daren't fail people. I started a group work total project in Birmingham in 1983, and it ran for 20, 30 years. So it's a very old thing. But please, it can only be a course that nobody depends upon.
Interesting.
Nobody depends upon.
Yeah,
Which gets to the heart of what I've always called the Burkhardt lie, but I will in future call it the Hornby lie, which is what you test is what you get. If you assume 0 equals 1, you can prove anything. You can even prove that I'm a lovable old fellow. It's false. And everything else that you said followed from that mistake. What you showed us are things that may be thoroughly worth doing, but they can't be part of assessment in any meaningful use of that word. That's my suggestion. So we should reduce the amount of assessment and get some kind of structure where these other activities are essential, and maybe get a teacher assessment, as in the old-fashioned German system, where you only take a limited number of sort of public exams and you get a high school grade, perhaps in an American style. But if you say what you test is what you get into all the difficulties that you highlighted, and we'll tie ourselves in knots.
Tony, by way of reassurance in some of those matters, of course, Cambridge has been working on and advising government and working collaboratively on the revised model of assessment in science GCSEs, which actually directly confronts these issues of the pressures from accountability on teachers in continuous or assessment, which contributes to the final grade. But Will, would you like to respond to?
Well, I think you've hit the nail on the head. I mean, I think the statement what you test is what you get is true when the test is high stakes. And in that sense, and all embracing, indeed, it's true when teachers take what happens in the assessment and use that to determine rather than inform what they do in the classroom. So there are plenty of classrooms out there in which far more is going on than is actually given in the assessment, and I wouldn't want to say otherwise. But it is simply that if we are stuck with high stakes assessment, then one way potentially of getting some of these skills into the classroom might be to find a way of assessing. But it needs, as you say, it needs non-traditional forms of assessment. So it needs coursework, it needs teacher evaluation, and it needs perhaps endorsements and so forth.
Yes, in the middle then.
Stephen Cowley, Faculty of Mathematics, University of Cambridge. I learnt my tack from Tony Gardner. I found the talk about Singapore actually quite revelatory because probably I should have known about it, because in some sense what Singapore have done is recognise that students have different abilities. But rather than actually saying that and then whispering it, yes, they've actually put it in little boxes. And actually, for many years, I've always believed that we've got to recognise that the students have different abilities. Yes, from Cambridge, I do not want the tail wagging the dog, but I think that, yes, the dog has got to realise that there is also a tail. Right? And we need to explicitly allow for the fact that different students have different abilities and they all need to have a fulfilling experience at doing mathematics. And while we all try and fit them into a one-size box, we are not going to achieve it. And the other thing is, as well as recognising that students have different abilities, I was a governor of a primary school for 4 years, you do need to understand that there are teachers with different abilities, and what the really brilliant teachers can do isn't necessarily what all the other teachers can do. And whatever we come out with, yes, it comes out of this project, it must recognise that teachers can only do so much. The other thing is have any of you been listening to Radio 4 this week and Cedric Villani? And he gave a talk in Oxford yesterday, and I'm sorry to say that I'm actually in Oxford at the moment, despite being from Cambridge. And he made the point that mathematics is a struggle. And the idea that everybody's going to enjoy all their mathematics is just not true. Some of the times you are going to struggle. I mean, I'm sure Rooney loves scoring goals, except Arsenal got 2. Yeah? But he'll have done his press-ups. If you pianist likes concertos, but they do their scales. And yes, I'm sure that I'd love as a student sitting there playing around on my computer, drawing little cars racing each other. But I also, yes, as somebody who interviews students, want them to be able to do their manipulation fast and accurately. And I'm sorry, that's boring, yeah, until you're really up to speed. And I think that we actually need to be practical. And to that end, my final word is politics. Whatever we do happens in the next 5 years, in the end we've got to sell it to government. And yes, in some sense, you've got to start now and make sure that all the parties, probably including the SNP if they're still with us, are on board, yes, so that whatever comes out gets adopted and doesn't go down some black hole again.
Thank you. Sneaking in 3 questions instead of just the 1, but that's good. I'll pass to our panellists in just a second. Can I just deal with your first 2 points about ability and effort, because I just want to combine them in some of the findings from international studies. Actually, in Singapore, underneath the idea of ensuring that there are sensitively designed curricula and separate pathways, there is also a very profound belief that in primary in particular, all children are capable of anything, depending on how it's presented to them and the effort that they put into learning it. Okay, and then it's recognised that if different patterns of attainment emerge over time, it is important to fine-tune the curriculum in the ways that you describe. But it's very important that that Confucian model lies underneath the whole of the education system, and that's enabled them to maximise their attainment. So this idea of effort and the idea of ability, I think, are very linked. And I certainly think that the model of ability that we've had in this country, where what you think a child is capable of becomes a self-fulfilling prophecy because you give them a highly limited diet, is highly problematic and totally at odds with what we find in Singapore. So I'll now pass it over really for comment from somebody who understands Singapore far better than I do.
Sorry.
So if you'd like to deal with the issue of the fine-tuning and the rationale behind the fine-tuning present in the different routes in the system. Okay. And then also this issue of, although in international studies, Singapore students do enjoy mathematics, when I go and observe mathematics classes in Singapore, they are working hard. They're not showing smiles, they're working hard and concentrating.
Okay, we have received criticism about our system. That is, we kind of like, stream them too early, to say that they are not capable of doing the harder course. But right now, what we have put in place are pathways. If let's say you have been, channeled to the let's say foundation maths, but if you show that you have the aptitude to do the standard maths, you can go back on. Okay, so it's not like a strict path. So there it's like there's a lot of lateral transfer, for you to move back to the higher curriculum. I'm not sure whether I've answered the questions that you asked. That it's actually very flexible.
Yes, I think that's quite important. There is in the Singapore system there is a lot of movement. Yeah. It's not that people once on a pathway are entirely fixed on that pathway.
Percentage in foundation maths?
Oh, I don't know these days. Percentage in foundation maths? The percentage of candidates?
The percentage,
yes, of children.
90% would do the standard maths.
Yes.
About 10% would do foundation maths.
Yes. Yeah. There's also a very interesting process that we were discussing outside the platform of a very important process of levelling at the point at which people enter schooling in Singapore. So those that haven't benefited from a very rich discussion of mathematics in the home, they are identified and they're given very, very supportive provision to bring them up to the level of the rest of the group so the group can move forward together and utilise social learning in the group in the early years of primary. So that they're again mitigating the impact of social background on attainment. Charlie, I'm being warned through my ear. We've got to be quick. Can you be quick? And I'll take one question.
The process of levelling you talked about when children enter primary school, how do you manage to achieve it so that, are they having extra time somehow? Because obviously they're not being withdrawn from the other children, otherwise they just get further behind. How does the levelling actually work in practice?
Sorry.
This is the process of identifying the small group who are struggling and how you give them special provision.
Okay, so they are taken out from the main group and then they have special lessons. So that's how it works. You're talking about the learning support program? Yeah.
The question was about selection.
How's the selection? Oh, okay. When they enter primary 1, they sit for special tests. When they enter primary 1,
But if they're taken out of the main group is still being taught maths, and they're being taught something which is helping them to sort of achieve a similar level to the main group. If they're not receiving extra curriculum time, I don't see how they can catch up. I'm interested in the actual mechanics of how it works.
They do receive additional curriculum time, Charlie, because they're in very small groups with very high-performing teachers. So in groups of up to 5. And so very small groups, very intensive tuition, very, very individualised. Time is pressing. Peter? Sorry, Charlie. Final. Peter.
Peter Phillips from Cambridge University Press. Fantastic presentation about Singapore and lots of really interesting and innovative things for us all to learn from. But one of the things that you didn't talk about very much is that not only is there a difference in terms of approach to teaching and assessment and so on, but there are also quite a lot of big cultural differences between the way that the teaching environment works in Singapore and in countries like the UK. So you have a culture of high expectations of achievement, of hard work, and of very significant parental support. And is there any evidence for how much of the high performance of Singapore comes from those cultural factors as well as the good features of the teaching environment that you're creating?
Yes, you're totally right about this culture factor. In fact, one of the challenges is that it's to convince parents that actually their children do not need additional help, tuition. So many of the students in our country, receive extra coaching outside of schools. The parents value the qualifications so strongly that they are willing to invest, their money, in getting this extra help. So that has been talked about even in our parliament, about this need for families to spend money on this extra tuition outside of school. So that could explain, why our achievement level is so high.
Thank you very much indeed. And can we thank our speakers this afternoon?